So a lovely example of bringing together innovative Spark projects and the ability to use our in-house physical lab was a stone bench that we did for Autodesk University. Essentially, the charge was to make a hyper-thin stone bench out of one piece of stone, which in any normal situation would snap. So how to make this work would be to start to think of combining it with another material, and we had the idea of combining essentially the world's oldest structural material, stone, with one of the newest, which is glass fiber reinforced plastic. And we essentially reinforced the stone with strips of GFRP. Essentially, it's like reinforcement with concrete, but there's a lot of data on that. So we did a series of tests, did a series of very unique analyses, worked with the whole team. It was digitally fabricated, installed, and it was not just a beautiful project, but it was one that performed. I jumped on it personally myself as soon as they'd made it. Where that led as a project, that Autodesk bench with GFRP into stone, actually expanded into a really applicable larger project here in Boston. And they have a very thin Guastavino tile semi-dome that we needed to reinforce. So we took what we learned from our sort of innovative small project where we've done physical testing and expanded that into applying a fiber reinforcing mesh, a slightly different material, different purpose, a different need, so we adapt as we go. But a reinforcing mesh that we applied over the Guastavino tile to reinforce it in areas that it now needs to be reinforced. So we took a very similar old material, combined it with a very new material. But in this particular case, as opposed to making something that was just pretty and interesting, we did it in terms of preserving and expanding the horizons for the next 100 years of an absolutely iconic and institutional project here in Boston.